Here we have a function f of x, which is equal to x, and another function g of x that's equal to x squared. We want to find f times g prime of x. So we're trying to find the derivative of the product of these two functions. So first I'm going to show you the wrong way to do this, only because I want you to realize the difference between the two. So the wrong way, okay, what you don't want to do is take the derivative of each function individually first. So find the derivative of f, so f prime of x. The derivative of x is 1. Then take the derivative of the next one, so g prime of x. The derivative of x squared would be 2x. And then saying that f times g prime of x is 1 times 2x, which is 2x. Okay, so this is the wrong way. So we're going to put a big X here. Don't do that. Okay, so it's kind of sometimes easy to think that that's what you should do because with addition and subtraction, you can find the derivative of the individual pieces first and then combine them. But when you're doing multiplication, you can't do that. So what we really want to do here is actually do the multiplication part first. So the right way to do this would be to multiply f and g together first. So f times g of x. So I'm going to multiply x times x squared, which is going to give me x cubed. Okay, then what I'm going to do is take the derivative of the product. So the derivative of f times g of x is going to be the derivative of x cubed, which is 3x squared. So that is the correct derivative, and that is the wrong way on the left. Okay, so make sure that we know that we're taking the product first and then taking the derivative of that product. So the way that we find the derivative of functions that are multiplied together is by using the product rule. So the product rule is basically saying that you have two functions. Okay, sometimes you can have more than two, but same setup here. So we have the first function, so f of x is our first function and g of x is our second function. You would have the first function times the derivative of the second function, and then we add that to the second function times the derivative of the first function. Okay, so first times the derivative of the second plus second times the derivative of the first. Now, because we're adding these two together, the order does not matter. So if you're trying to remember the product rule and you flip-flop it somehow and you say it's the second one times the derivative of the first plus the first times the derivative of the second, you're going to end up with the same answer because you're adding. So the order does not matter, but typically this is the way we say it is the first one's first and then times the derivative of the second. So let's look at an example here. So here we have a function, f of x equals this, and there's two binomials being multiplied together. So we're going to find the derivative using the power rule and the product rule. So I personally would use the product rule here because that's usually going to be a little bit easier. There's less math involved if you're using the product rule versus the power rule. But I'm going to show you that you can use both. So if you forget somehow what the product rule is, you can use the power rule depending on what you have in front of you. So if I were to FOIL this together, so let's put power rule here. So if I were to FOIL these two binomials together, I would get that f of x is equal to, so if I FOIL, let's see, we'll get 2x to the fifth plus 5x to the third plus 6x to the third plus 15x. I can combine my like terms together and I can get 2x to the fifth plus 11x to the third plus 15x. So we've just rewritten f of x to be in expanded form. So here we have it's expanded, it's in standard form. I can take the derivative of this now by using the power rule. So my derivative would be 10x to the fourth plus 33x squared plus 15. So that is my derivative. When the function gets a little bit more complicated, it's going to be easier to use the product rule. You might think that this time it's the power rule is better. It depends on the function. So here we're going to use the product rule. So product rule. So the product rule says that we take the first, so we're going to call that's the first function, and this is the second function. So we're going to do right to the derivative. So f prime of x, the derivative, is going to be the first, which is x squared plus 3, times the derivative of the second. So the derivative of 2x cubed plus 5x is going to be 6x squared plus 5, plus the second, which is 2x cubed plus 5x, times the derivative of the first. So the derivative of x squared plus 3, so that's going to be 2x. So here, if we FOIL the stuff together, let's see, we're going to get 6x to the fourth plus 5x squared plus 18x squared plus 15 plus 4x to the fourth plus 10x squared. So if I combine my like terms together, I end up getting 10x to the fourth plus 33x squared plus 15. So we get the same exact answer, doing it two different ways. Okay, so now we're going to look at this example here. So here we have f of x is equal to x e to the x, and we want to find f prime of x. So again, we want to break this up into the first and the second. So here the first is going to be, I'll just put a 1 here, is x, and e to the x is going to be the second one. So f prime of x, using the product rule, we have first, which is x, times the derivative of the second. So the derivative of e to the x, remember, is e to the x. And then we're going to add the second, which is e to the x, times the derivative of the first. So the derivative of x is just 1, so we don't really need to write anything there. So this is our derivative. If we wanted to simplify it a little bit, we can factor out the e to the x. So I'm going to just do that. So I'm going to pull out the e to the x, and then we're left with x plus 1. Okay, so either one is correct. On an AP test, you don't need to simplify things all the way. So if this was an open-ended question, you can leave it as the top one. However, if it was a multiple choice question, they usually show the answers for the multiple choices in simplified form. So even though you might not need to simplify it yourself if it was open-ended, you need to be able to recognize what it is simplified for multiple choice questions. So usually I will simplify it all the way so we can get used to seeing what it looks like. Okay, so then part B of this says find the nth derivative, f to the n of x. So the nth derivative. So we want to start looking for a pattern. So we know what the first derivative is, and I'm going to use the simplified version when I'm finding the next derivative. So if I want to find, let's say, the second derivative, f double prime of x, I'm going to take the derivative of this. So my first in this case would be e to the x, right? That would be my first, and this would be my second. So I'm going to use first e to the x times the derivative of x plus 1, which is just 1, plus the second, which is x plus 1, times the derivative of the first, which is e to the x. So again, I'm just going to simplify it a little bit here. So they both have an e to the x. So if I pull out an e to the x, I have 1 plus x plus 1, which is really going to be e to the x times x plus 2. Okay. I could find the third derivative by using this final answer for my second derivative and finding the derivative again. But if we look for patterns, right, when I had the first derivative, I had e to the x, x plus 1. When I have the second derivative, I have e to the x, x plus 2. So by this pattern, if I found the third derivative, it would be e to the x, x plus 3. And the fourth derivative would be e to the x, x plus 4. So if I'm trying to find e to the x, I'm trying to find the nth derivative. We've got f, the nth derivative of x. We're going to have e to the x, x plus n, right? Whatever the number of the derivative is, we're going to add to the x here. So that's just a cool thing about e to the x. So there's that. Okay, so then we're going to look at this other example here where we want to differentiate this function. So again, that differentiate just means find the derivative. So here we have a and the bt. So a and b are going to be constants, and t is our variable. So if I want to find the derivative, f prime of t, we're going to take the first. So the first, I'll put a 1 here and a 2 here. So the first is the square root of t. So first times the derivative of the second. So the second is a plus bt. A is a constant, so the derivative of that is just 0. And then the derivative of bt would be b. So I'm just going to multiply by b, plus the second, which is a plus bt, times the derivative of the first. So the first is the square root of t. Now, remember that the square root of t is the same thing as t to the 1/2. So when I'm taking that derivative, I'm just using the power rule. So I'm going to have 1/2 t to the negative 1/2. So we've got the first times the derivative of the second, plus the second times the derivative of the first. Okay, so I'm going to keep going with this. So again, if this was an open-ended question and said find the derivative, you could leave it like that because you've plugged in everything properly in the derivative. But I'm going to keep going since we most likely will see things more simplified. So f prime of t is equal to, so I'm just going to kind of rewrite this so it looks a little bit nicer. So b radical t, and then I'm going to make this a plus bt over 2 square root t, just to rewrite it. And then I could add these together if I have a common denominator. So really this denominator is like a 1. So if I multiply by 2 root t here and here, I can simplify this even further. So f prime of t is going to be equal to 2 bt. So if I multiply 2 root t times b root t, I get 2b times t. And then plus a plus bt over 2 root t. And then if I simplify the top a little bit, I can add the 2bt and the 1bt. So I get a plus 3bt over 2 root t. And that would be simplified all the way.